Good afternoon. So we'll be just starting with the today's session. So in the last class we were discussing about the feedback different feedback configuration. So feedback configuration. So we have seen series, shunt series, and we just seen that so how the on employing the negative feedback, how the input and output impedance amplifier can be able to control. So in that series shunt configuration, in that input impedance is going to increase factor of 1 beta. At the same time, the output impedance is going to reduce by factor beta. So that we have been seen for the for the so for the ideal case we have seen, and we the expression for us as well as shunt as well as all the configuration we have seen. So today we are going to see the we are going to study about the another class of amplifiers where we are going to study. So this is the power amplifier topic. So till now we have considered about a feedback amplifier and different types of configuration and what are the negative feedback, different configuration, and how it is going to be controlled at input and output. So this is about the third module, half of the module. So another half of the module will be dealing with respect to power amplifier. So output stage and power amplifier. So before going to this, before going to start with the power amplifier, so we should know what is power amplifier, and also we should know where exactly. So where exactly you can use, where you are going to use this power amplifier circuit. So power amplifiers actually, so whatever the transistors we have seen, so the classification and the amplifier, the transistor BJT as well as the MOSFET, which are being used as an amplifier. So that type of amplifiers which I was studied in the module 1 and module 2, that is about the small signal amplifier. So we are going to call it as a small signal amplifier because on giving a small signal, so you are going to get amplification, and the maximum output voltage will not be exceeding the limit. So you will be having the whatever the output voltage as well as the current signal which you are going to get in the case of BJT as well as a MOSFET. So that voltage as well as the current will be of very small amplitude. So because of that, we are going to call it that as a small signal amplifier. Whereas in the communication field it is concerned, so in the communication when you are going to transmit a signal, so signals from the transmitters uh, which you have studied very low amplitude and will be not able to deliver the load to directly. So it is going to be, so whatever the BJT as well as the MOSFET which you have considered, so these transistors will not be capable of driving the load directly. So how why it is not able to drive the load directly? Because the load, so which is going to have, which needs a higher power signal, so not with respect to just current or the voltage signals. So it requires some high power signals, so which is going to be driving the load. So normally, so output stages, so we are going to use the large signal amplifier. So at the output stage, we are going to use this power amplifiers in order to drive the load. So we are going to use this power signal amplifier. So the small signal amplifiers which are there in the BJT as well as MOSFET which we have studied. So this is just usually that can be used for amplification as well as you can use for switching applications for small signal switching as well as small signal amplification. Whereas for this voltage amplifier, so we are going to this small signal amplifiers will not be having the power handling capability as well as the power efficiency, so is of very little concern. So we are not going to have that power efficiency, power dissipation, all these things will not be dealt by using this power amplifier, by using this small signal amplifier. So for the voltage amplifier which is going to provide an voltage amplification, so primary is to increase the voltage of the input signal. So what is the main thing of the voltage amplifier? So voltage amplifier main concern is that whatever you give the small signal voltage, so that amplification it is going to be done at the output side. So that is about the main concern. That is just to increase the voltage of the input signal. So that is about the small signal amplifier. So when you are going to use common source, common base, common emitter, as well as common base, common connector, so all these configurations, so whatever you are going to use there, you are going to use only for amplification purpose you are going to perform. Whereas on the other hand, so when you are going to deal with a large signal, so we are going to use a power amplifiers, so which is going to have a sufficient amount of power need to be used, or it is needed to be delivered to the load, so in order to drive. So for this for that example, we can take in the field of communication field, we can see, so output stage is of suppose if it is a speaker is the output signal. So for the speaker it will be, in order to provide a that in order to drive the output load to the speaker or any other power device, basically the typically it will be requiring about a few watts to tens of watts of power is required. So for that, in order to generate that amount of power, then only you can use it as a speaker for the load. So in order to generate, so we have to construct a device which is going to perform a large signal amplification, or else it is also called as a power amplifier. Since these power amplifiers will be used at the output stage, hence you are going to consider as a, will be majorly we are going to deliver for the high load. So we are going to construct this type of a large signal amplifier at the output stage itself. So in order to deliver a high load, so it has to be delivered a few watts to tens of watts it need to be delivered. So but this amount of power will be not generated by the small signal amplifier. And what are the main features of this large signal amplifier are? So the main important features are circuit power efficiency. So it is going to have power efficiency, the main feature. So it is the total circuit's power efficiency, as well as the maximum amount of the power that the circuit is capable of handling. So before delivering the load, so how much power it is able to handle. So that is the maximum amount of power, and impedance matching at the output device. So in order to provide a maximum signal to be delivered at the load, so it has to provide a impedance matching. Okay, whether my voice is audible?
Yes,
Okay,
sir.
okay.
Yes, sir.
So here in this chapter, we are going to study about that type of power amplifier itself. So this, even though in this circuit and all, you're going to see the same type of transistors and all, but you have to assume that it is not just a transistor; it is a power amplifier. So if you see the BJT or the FET, which you're going to be observed over here in the circuit diagram and all, so that circuits in the BJT or FET will be considered as the power BJT or power MOSFET. Okay, so because it is going to provide a high large signal amplification is going to be performed by those power amplifiers. So which is going to be delivered to the load. So that is going to be the function of this power amplifier. So what is the important function of an output stage of an amplifier is to provide an amplifier with low output resistance. That is what, so that it can deliver output signal to the load without loss. So that is we have seen. So what should be the output resistance? So the output resistance should be low, so that the maximum output signal can be delivered to the load without any loss. So we have seen that load resistance RL will be there. So amplifier will be having the output resistance. So the output resistance of that amplifier so should be very small, such a way that it can deliver maximum signal to the load without any loss. So if the output resistance of the amplifier itself is large, then the power signal loss will take place between this and the load. So since the output stage, since I'm just dealing about the power amplifier, so the output stage will be made up of the final, that will be the final stage of the amplifier. So it will be relatively large signals. So large signals, that is in terms of power signals, will be available over there. So the small signal approximation and all cannot be applicable over here. So whatever the small signal approximation and the model which we are doing in the case of small signal analysis and all, so the same small signal approximation and all model cannot be applicable for this large signal amplification. And And one more important thing in the large signal amplifier is that linearity is very important requirement. So linearity means there should be no non-linear distortion. That means so if it is not having any non-linear distortion, in that case the output signal must be proportional to that of input signal. That is nothing but linearity. So that linearity must be satisfied in the case of large signal amplifier. And then, so what are the important challenges that is requirement in an output stage is how the efficiently the amount of power is delivered to the load in an efficient manner. So that means, so we know that the output signals of the amplifiers coming out of the amplifier will be very much higher. So typically in terms of watts it will be there. So how efficiently the power will be delivered to the load. So efficiently, that means how efficiently means without any power loss or power dissipation in the output stage, and how efficiently it is going to be transmitted to the load in an efficient way. So that is the main concern of the main challenging requirement in the case of output stage. So output stage typically it is made up of large signal amplifier, and this large signal amplifier will be having the large signals in the terms of powers and power signal. So how efficiently these transistors, so large power transistors, it is going to deliver the power to the load in an efficient way. So that is very important stage in the output stage of an amplifier. So that is this implies that power dissipation in the output stage must be as low as possible. So that is the main requirement. So efficiently how the power can be transmitted. So if the power itself, even if the power in the electronic circuit itself is consuming means it is going to dissipate as a heat. So right, so that power dissipation from the transistor itself, if it is less, then efficiently it is going to transmit to the load. So that is one of the requirement, that is the power dissipation must be as low as possible. And then because of that whenever you're going to operate that, suppose when the power dissipation will occur, so when the power dissipation will occur, so in the reverse bias operation, whenever the typically whenever you're going to have a reverse bias operation, it normally it is going to increase the junction temperature, that is 150 to 200 degrees Celsius for a silicon device. So maximum temperature it can withhold. So for small signal transistors and all, so it is going to be less than 150 degrees Celsius. So for this maximum power transmission, so for this power transistors and all, so it is going to be greater than 150 to 200 degrees Celsius maximum temperature withstand capability will be given. Hence a high conversion efficiency is also required. So whenever it is going to be converted from one form to another form, so the power conversion efficiency for the circuit is also very important. So power dissipation should be less and power conversion efficiency must be high. So how efficiently you are going to convert this power. So in this chapter we are going to study about the different power amplifier stages. So depending upon the context, as I told, so whenever we are going to consider high power means generally it will be greater than it will be in terms of watts, few watts to few kilo few tens of watts. So normally it will be in terms of watts only. So how efficiently this how efficiently this power is going to be used, and it is going to have a less power dissipation when it is being transferred into the load resistance. So across the load, how efficiently it is going to be converted. So based upon this power amplifier at the output stage, so the classification has been done based upon the operating principle. So how the transistor is being operated. So operation in the sense we have seen in the biasing method. So the biasing of the transistors and all we have seen. So biasing of the suitable point, so it is going to be gives a proper output. Large signal amplification will be getting in the case of small signal analysis we have seen. So upon suitable operating the transistor with a quiescent point, so proper quiescent point. So in the active region, if you are going to operate the transistor in the active region, then you will be getting the maximum amplification. So it should not be too much close to the saturation as well as too much close towards the cutoff region. So if that is the point, quiescent point, if it is get selected, which is going to be put on the DC load line, so that in that region, so you can get the maximum amplification over there. So that is that is what we are going to say that the transistor so being operated properly. So Based upon this, so classification of the power amplifier is also being done based upon the operating angle. So operating angle and based upon the quiescent point selection. So where exactly the Q point is being selected, and based upon that, how we are going to get the output. So that is what based upon the classification we have done. So classification of power amplifier, that is normally the power amplifier here he has just mentioned the power amplifier is a normal amplifier with a high power output stage. That means the output power will be very high when compared to the small signal amplifier. So transistor as an amplifier, if you consider, so the normal transistor will not be delivering that much power, whereas this power amplifier at the output stage is going to deliver a high power. So that is the basic difference, and for this we are going to consider the discrete and integrated circuit power amplifiers will be presented over here. So we are going to consider even the discrete power amplifier as well as the IC based power amplifier also going to be considered. And in this we are going to see what are the different classification of the power amplifiers. So amplifiers can be categorized. So we can see the classification of the output stage of an amplifier. So in this figure we can see, I just explain and I'll just go through the each figures and all. So classification of power amplifiers. So amplifiers, power amplifiers are being categorized into different class based upon the amount of output signal varies over the one cycle of operation for a full cycle of input signal. That means for a given full sinusoidal waveform input signal, how the amount of output signal varies for a one cycle of one full cycle of input. So how much is the output it is going to vary. So based upon that, there is the operating angle. So that is the operating angle for a one cycle of input signal, how the output is going to vary. So that based upon that, we are going to classify the power amplifiers. So class A amplifier is going to have, you can see this is a class way. So you can see for a given input signal, so we can say that given with a small with a sinusoidal signal, so which is going to have one full cycle of the input signal has been given for this one signal type of input. So you are going to see this figure A corresponds to the output of the class A amplifier. In this class A amplifier you can see, so the operating the output signal varies for a full 360 degrees. So that means output signal is varying for a full 360 degrees. So here 0 to 2 pi, 0 to pi, pi to 2 pi. So from 0 to 2 pi, the output is signal is varying with its full length, full amplification you'll be getting as the output over here. That means the operating for the class A amplifier, if we can see the output is varying for 0 to 2 pi. That means for a given input cycle, for a given one input cycle, so output is also varying with respect to full cycle output you are going to get. So that is about the class A amplifier output. So in order to get this type of output, that means in order to get a full output for a given input signal, if you want to get a full 360-degree output, that means you are going to have without any loss of the signal. If you want to get, means the what should be the Q point to be selected. So Q point, that is the operating point for this transistors, need to be biased at center of the load line, correct? So if you can see, so we can see the analysis over here. Here they have not given any analysis. I'll just post in the group. So tomorrow onwards I'll just open with new document. So in that I will be showing, so what is the class A amplifier, and how the output characteristics VCE versus if you can see, so the output VCE versus IC characteristics, if you can see, so that is output characteristics of the amplifier transistors and all. So if you can see, you can just recall. So output current with respect to output collector to emitter voltage you can consider. So output current with respect to output collector to emitter voltage. For that, if you are going to plot a DC load line, so we are going to have output characteristics. So we are having a families of curves or different collector current for a different VCE. So you can see, you can plot a DC load line, load line, and then we can say upon suitable selecting the Q point exactly at the center. So exactly at the center if we select, so that for a given input signal you will be getting full length amplification without any distortion. So without any clipping or without any clipping of the circuit, clipping of the output happen. So that is about the Q point. So here class A amplifier will just be operating at the Q point exactly at the center of the load line. So for which you can see there is no output is going to have a full length output without any clipping at the clipping of this output will not take place across any of this one. So this is about the class A amplifier. So output signal varies over the full cycle of the input signal. And coming to the class B amplifier is concerned. So in this class B amplifier, you can see this is the waveform output waveform which you are going to get. So we will go in detail. So in the next further classes and all, so we are going to go for each of the signals or each of the classes amplifier we are going to see, and how we are going to get this output, and how we are going to do the transfer characteristics, and transfer characteristics, power conversion efficiency, power dissipation. So each of the class amplifiers we are going to do perform the analysis, and we are going to see which is going to have more power efficiency, and what type of advantage and disadvantage which is going to have for each of the power amplifier stage we are going to see in detail. So only thing is that you are going to have class A amplifier will be having a full length output cycle you will be getting. And coming to the class B amplifier output, if you can consider, so you can see that class B amplifier. So the Q point is located at the cutoff. So you can see, you just assume this is the waveform. So this is the current versus okay. So this is nothing but a current versus voltage, current versus voltage, which is nothing but output characteristics VCE. So collector to emitter characteristics, emitter voltage and current. So x-axis and y-axis is current. So you can see there will be families of curve like this. So in that, if you are going to plot the load line, so sorry, in that if you are going to plot the load line, if you are selecting the load point exactly at the center, so what will happen? So you will be getting this type of output. Suppose the Q point is selected such a way that it is selected at the cutoff point. So if it is selected across this the along the base of the x-axis, so if you are going to find out point Q point is selected means only positive half cycle will be getting the output. So negative half cycle will get clipped off, and because of which you can see the output for a given input full length of cycle you will be getting only one half of the cycle, that is 0 to pi you will be getting as the output. So this is about the class B. So operating angle. So Q point is located at the cutoff region. So since it is located at the cutoff region, so output signal varies only for one half of cycle of the input. So for a given one cycle of input, so only the output will be having only one half of the cycle of the input. So single class B amplifier. So if you are going to have a single class B amplifier, so it is going to provide only one half of the cycle at the output. Suppose if you are going to have a second class amplifier, so which is going to be having different input configuration means, then you will be getting the uh, remaining half of the cycle can also be you can obtain. So this is with respect to one single amplifier. So class B amplifier. If you want to get the output for the second half of the cycle, that means if you want to bias in the opposite direction such a way that you will be getting the negative half of the cycle. So in that case, you are going to get the full one length for a given input cycle. You will be getting both a positive half as well as a negative half, so that you can get back to like class A amplifier. So if you are going to have a two class B amplifier, so biased in opposite direction, such a way that you will get a first half cycle with respect to one amplifier means another class B amplifier is going to provide the another half of the cycle. So only together alone, if you are going to consider the class B amplifier, only for a given one input of the cycle, so you will be getting only one half of the cycle. Suppose if you are going to have another clubbed with another class B means you will be getting the entire cycle. So that is then you can club the output of these two amplifiers, so that each class B amplifier will be considered as a push amplifier, push pull configuration. So in that case, we are going to call that configuration when you are going to have a two class B amplifier to get the full one cycle of the output. So you are going to call that configuration of the class B amplifiers as a push pull configuration of the amplifier. So in that push pull means, so you'll be having one half of the cycle and another half of the cycle from the another output. So you're going to call that as a push pull, so that each will be operating with respect to positive as well as negative half of the cycle. Okay, so that is about the class B amplifier. So here, so there are some advantage and disadvantage also it is there. So in that case, so if you go for the class AB amplifier, so this is class A amplifier, class B amplifier. Now if you go with the output of the class B amplifier, so this is nothing but a class A amplifier output. So wherein which you can see this is the complete output waveform, so which you are going to get over here. So in that case you can see, so here dotted line indicates that is a baseline. So and then you can see that if the Q point, so as I told you, it is going to operate with respect to operating point. So if the Q point which you are going to select at the exactly at the center means you will be getting this output. If you select the Q point at the cutoff means you will be getting this type of output. For class AB, not overcome the drawback of these two. So what you are going to have is you're going to select the Q point just below the center of the center of the load line, at the same time just above the cutoff. So to select the Q point to operate just below the center of the load line as well as above the cutoff point. So when you are going to do that type of operation, then the operating angle of this class AB amplifier will become greater than 180 and less than 270. So here in this case the operating angle is the entire 360 degree. Here it is 180 degree. Operating angle is 0 to 5, that is 180 degree. When you consider here, so you'll be getting, so here it will be pi is there, so between that pi, so you can see the output is varying greater than pi. Also you can see the of the output is going to have. So in that case the operating angle for this class AB amplifier is going to have greater than 180 and less than 360. That means it will be equal to greater than 180 and less than 260, 270. So less than 270, less than 270. So that is the operating angles for a class AB amplifier. So this in this type of output waveform for which you are going to get the class AB amplifier is to be biased the amplifier in such a way that greater than the cutoff point and less than the center of the load line. If you are going to operate, then for a given one input cycle you are going to get the output which is going to be greater than 180 degree and less than 270. So that is the operating angle for this class AB amplifier. And if you are going to operate with the class C amplifier, so when you are going to consider, this is the last figure of the amplifier, wherein which you can see current versus time. If you can see, this is the output waveform for the fourth classification of the amplifier, in which you can see for a given input cycle you can say the output is less than pi. That means less than 180. Now to get this type of output, where I should bias is, so the biasing point will be below the cutoff point. So if I'm going to so in this case it is what, so biasing point is at the cutoff point, so for which we are going to get a full positive half cycle. Whereas if the biasing point of the transistor is below cutoff, that means below cutoff means below the cutoff line, if I'm going to select or at this point means, so you will be getting only this much of the output waveform you will be getting. That means only the peak signal of the input signal, so it will be generally less than pi. So for which you are going to get, so only the positive peak of the output you will be getting, and the remaining thing you can see duration will be getting clipped off. So this is what you are going to get as a class C amplifier. So this is the class A amplifier, class B amplifier, class AB amplifier. So this is class AB. So this is the name of the class C amplifier stage. So based upon this classes classification, so we are going to see in detail with respect to what and all the transfer characteristics. So transfer characteristics is nothing but how the input voltage and the output voltage are correlated. So when you vary the input voltage, correspondingly the output voltage across the amplifier is also going to vary. So based upon that, you are going to say that whether it is going to have so what is the power efficiency, power dissipation, transfer characteristics and conversion efficiencies. These four important characteristics for each of the classification you are going to learn in detail. So in the next class I am going to do all those things. So one on amplifier I am going to consider. So class A amplifier, if I am going to consider means, so what is the operating angle, everything we have seen. So tomorrow also I will just start with that and I will show the pictorial representation, and so that you will come to know so how the classification has been done. and after that we have to see what are the advantage and disadvantage of each of the classification, and how we are going to find transfer characteristics, as well as the power conversion efficiency, power dissipation for each of the classification amplifier you are going to learn in detail. So with this I'll just conclude today, because I'm having this one, what is that, um, what is it, 8 sem project presentation is there. So I'll just go over that, so that I'm just winding up this today's class with 10 minutes early. Okay. Okay, so we'll meet you tomorrow. So morning, we'll just start with the class A amplifier. Okay, bye. So I have just posted, so all of you might have seen the assignment number 2, right? So I have just posted assignment number 2, and assignment number 1 also I have just posted in the morning itself. So that is because in the last time I have posted in the file, so since you cannot able to reply or you cannot send it through the MS team, so I have not evaluated that marks for this assignment marks. So I just posted again that same assignment number 1, so kindly within due today, so I have just given due as today itself. So whatever you have written for the assignment 1 questions and all, so kindly upload that materials into corresponding by turn in, and you have to return the assignment. Okay, so if you fail to do so by today, so later it is not going to take, so you'll be losing the assignment marks also. So is it clear? So assignment number 1, it is due is today, and for assignment number 2, so due is for 26th. Sorry, 26th. Okay, 26th of this month I have just given as a due. So within 26th, you have to submit the assignment number 2. So if you are not doing so, again you have to return it through the MS team itself. So morning I have just posted both the assignment 1 as well as 2. So kindly just return that assignments. Okay, is it clear? ಕೇಳಿಸ್ಕೊಂಡ್ರನ?
Yes, sir.
So you have to return. So first assignment as soon as possible. So today itself. So you have to return. So you have to submit it back. And for assignment 2, so you have time deadline for 26th. So before 26th you can submit. So first assignment ಗೆ ಇವತ್ತೇ submit ಮಾಡಬೇಕು, return ಮಾಡಿ. So you have submit, because I have posted in the files, right? So I just they told to put it in the MS team only, so that everyone, any officials, anyone can log in, means so that he can see. For that purpose, even HOD sir told to put in assignment in this one only, so that it will be visible for everyone who will be coming. Okay, so kindly post by today itself. Otherwise, I will not evaluate that assignments, so marks will be reduced. So 3 assignments totally I will be giving for each internals. So before the internals, I'll be giving each an assignment. So each will be carrying equal weightage. So average of the 3 it will be taken, and so that it will get reduce the marks. So kindly post the other assignment. With this, I'll just conclude today's class. So I'm just having a project presentation over here.